Fundamentals Chapter 3. Physiology and Histology of the Skin. Learning Objectives. After completing this chapter, you will be able to describe why learning the physiology and histology of the skin makes you a better esthetician. Describe the attributes of healthy skin. Distinguish the 6 primary functions of the skin. Explain the function of each layer of the skin, from the deepest to the surface. Identify a hair follicle as an appendage of the skin. Identify nails as an appendage of the skin. Describe the functions of the 2 types of nerves. Explain what is produced by the 2 types of glands of the skin. Distinguish the factors influencing skin health. Describe why learning the physiology and histology of the skin makes you a better esthetician. Estheticians have an opportunity to study a most fascinating science. Skin histology and physiology involves the study of the anatomy, layers, and functions of the skin. Recall that Chapter 2 defined physiology as the study of the functions and activities performed by the body structures, including physical and chemical processes. Histology is also known as microscopic anatomy, the study of the structure and composition of tissue. So, skin physiology and histology involves the study of the structure and composition of the skin tissue. These are the foundational sciences estheticians need to have a solid grasp of before caring for the skin. Estheticians who specialize in the health and beauty of skin are sometimes referred to as technicians, skin therapists, or specialists. There is much more to being an esthetician than simply performing facials and selling products. Figure 3.1. As scientific research in the industry changes and advances constantly, new understandings of how the skin functions and interacts with new technologies are emerging. How other body systems are integrally linked with the integumentary system are being revealed as researchers look for new ways to treat chronic diseases and disorders, work on anti-aging efforts, and battle cancer. Estheticians must commit to being lifelong learners. Clients value an esthetician's comprehensive understanding of the skin in general. Committing to becoming a skin expert means you develop an understanding of your client's unique skin characteristics and responses. You can make personalized treatment recommendations and prescribe a home care regimen that will help keep the skin healthy and vibrant. By educating clients, estheticians are sharing their knowledge and expertise. An esthetician's primary focus is on preserving, protecting, and nourishing the skin. Estheticians should study and have a thorough understanding of the physiology and histology of the skin because the complexity of the skin is astonishing. The layers, components, and functions all work with other body systems to protect and regulate the skin and other parts of the body. The study of skin physiology and histology includes learning about the aging process as well as interpreting the effects of ultraviolet, UV, damage, hormonal influences, and nutrition on skin health. Each of these factors affect the skin's health and appearance. There is much to study about the body's largest organ and how to best maintain its optimum health, and with a deeper understanding, the skin therapist can confidently treat this sophisticated system. Describe the attributes of healthy skin. Skin, or the integumentary system, is the largest organ in the body. It is a strong barrier designed to protect us from the outside elements. Skin layers, nerves, cellular functions, hair follicles, and glands all work together harmoniously to regulate and protect the body. Hormones, growth factors, and other biochemicals control the skin's intricate functions. Figure 3.2. The basic material and building blocks for our body's tissues are proteins. Amino acids are the building blocks of proteins. Amino acids form peptides, and peptides form proteins. Proteins have many roles in maintaining skin health. Our skin is an industrious manufacturer, with miles, kilometers, of blood vessels, millions of sweat glands, and an array of nerves within a network of fibers. Appendages of the skin include hair, nails, sweat glands, and oil glands. Healthy skin is slightly moist, soft, smooth, and somewhat acidic. Check in. List 5 interesting facts about healthy skin. Distinguish the 6 primary functions of the skin. The skin is similar to a multifunction tool. It acts as a shield for the body. It is waterproof and an insulator that protects the body against extreme heat, cold, and damaging UV rays. Skin is a barrier that protects against harmful chemicals and bacteria, preventing infection. Skin plays an important role in bone health by producing vitamin D. In addition, our skin is a huge sensory storehouse that keeps our brain in touch with the world around us. Skin does all of this while being flexible enough for the body to engage in motion while maintaining a healthy exterior to allow us to look good and feel comfortable. For these reasons, the 6 primary functions of the skin are sensation, protection, heat regulation, excretion, secretion, and absorption. Sensation. Touch is one of the first senses to develop. Nerve fibers in the skin sense when we are touched. Depending on the type of stimulation, sensations felt on our skin cause us to feel, react, or move. Different nerve sensors help us to detect different sensations and perceive changes in our environment, such as heat, cold, touch, pain, and pressure. Figure 3.3. Nerve sensors send messages to the brain and motor nerves send messages back to relay to the body how to respond. The sensation of heat will cause us to pull away from a hot stove burner. A massage sends messages to the brain through nerve stimulation and lowers stress in the body as well as promotes circulation. Studies have shown stress reduction in babies and older adults when they experience more touch and interaction with others. Sensory nerve fibers are most abundant in the fingertips and are designed to be one of the most sensitive parts of the body. Protection. The skin is a thin, yet strong, protective barrier to outside elements and microorganisms. It has many defense mechanisms to protect the body from injury and invasion. Sebum on the epidermis gives protection from external factors such as invasion by certain bacteria. The acid mantle is the protective barrier made up of sebum, lipids, sweat, and water. These components form a hydrolipidic film to protect the skin from drying out and from exposure to external factors that could damage it. Hydro means water. Lipidic means oil. A hydrolipidic film provides an oil-water balance on the skin's surface. The acid mantle has an average pH of 5.5. The balanced pH of the skin is important to protect the body from pathogens and regulate enzymatic functions. The acid mantle is part of the skin's natural barrier function. The barrier function is the skin's mechanism that protects us from irritation and intercellular transepidermal water loss, the water loss caused by evaporation on the skin's surface. Lipids are substances that contribute to the barrier function of the epidermis. Lipids are protective oils and are part of the intercellular matrix, fluid, between epidermal cells. Damage to the barrier layer is the cause of many skin problems, including sensitivities, aging, and dehydration. Figure 3.4. Did you know? Everyone has the same number of melanocytes, the cells that produce skin color. Some people's cells produce more melanin than others. Eye color is also the job of the melanocytes. Melanocytes are the cells that produce pigment and protect our bodies from harmful ionizing UV rays. Melanocytes produce pigment granules called melanosomes. Melanosomes produce a protein called melanin. Melanin travels from the deeper basal cell layer of the stratum germinativum to the surface through finger-like projections called dendrites, acting as an umbrella to shield the skin from the negative effects of the sun and indoor tanning. UV rays can damage the DNA in melanocytes and cause skin cancer. The 3 types of skin cancer are discussed in Chapter 4, Disorders and Diseases of the Skin. The skin's most amazing feature is the ability to heal itself. Skin can repair itself when injured, thus protecting the body from infection and damage from injury. Through a hyperproduction of cells and blood clotting, injured skin can restore itself to its normal thickness. Hormones such as epidermal growth factor stimulate skin cells to reproduce and heal. Proteins and peptides trigger fibroblasts and cells to rejuvenate. Skin cells are activated to quickly repair the skin. Other protective components of the skin include cells active in the immune system. These processes are discussed later in this chapter. Did you know? The microscopic view of the structure of the epidermis resembles a brick wall, the cells are the bricks, and the intercellular matrix is the cement mortar between the bricks that holds everything together. Heat regulation. The body's average internal thermostat is set at 98.6 degrees Fahrenheit, 37 degrees Celsius. When the outside temperature changes, the skin automatically adjusts to warm or cool the body as necessary. The body maintains thermoregulation through evaporation, perspiration, radiation, and insulation. Millions of sweat glands release heat from the body through perspiration to keep us from overheating. We then cool ourselves through evaporation on the skin's surface. Blood flow and blood vessel dilation also assist in cooling the body. Did you know? Sometimes the terms pore and follicle are used interchangeably. Pores are actually tube-like openings for sweat glands on the epidermis. Follicles are tube-like depressions with oil glands attached to them. Some follicles have hair and others are hairless. When clients refer to their pores, they may be actually referring to follicles. We protect ourselves from the cold by constriction of the blood vessels and decreased blood flow. Additionally, the body's fat layers help to insulate and warm the body. Hair follicles also help regulate body temperature and protect from heat loss. When we are cold, the erector pili muscles attached to the hair follicles contract and cause goosebumps. This reaction is thought to warm the skin by the air pockets that are created under the hairs that stand up when the muscle contracts. Shivering is also an automatic response to cold and a way to warm up the body. Excretion. The sudoriferous glands, also known as sweat glands, excrete perspiration. Many people believe that sweat detoxifies the body, but less than 1% of the body's detoxification comes through perspiration. Sudoriferous glands serve to prevent the body from overheating. The liver and kidneys do the detox work. Heavy sweating can cause a loss of fluids, dehydration, and the loss of the mineral balance needed to keep the body functioning optimally. Sweat, just like sebum, is also part of the acid mantle. The functions of these glands are discussed later in the chapter. Secretion. Sebum is an oily substance that protects the surface of the skin and lubricates both the skin and hair. Sebaceous glands, also known as oil glands, are appendages attached to follicles that produce sebum. These oils help keep the skin soft and protected from outside elements. The skin is approximately 50 to 70% water. Sebum coating the surface of the skin slows down the evaporation of water, also known as transepidermal water loss, and helps maintain appropriate water levels in the cells. Emotional stress and hormone imbalances can stimulate oil glands to increase the flow of sebum, which can lead to skin problems such as acneic breakouts. Activity. Mnemonic. A mnemonic is a word or a verse that helps you remember something. Create a mnemonic to help you remember the functions of the skin. Share your mnemonic with your classmates. Absorption. Absorption of chemicals, hormones, moisture, and oxygen is necessary for our skin's health. Vitamin D is also synthesized and produced in the skin upon exposure to the sun. The skin selectively absorbs topical products, serums, and creams through the cells, hair follicles, and sebaceous glands. While absorption is limited, some ingredients with a smaller molecular size can penetrate the skin. The penetration ability of the ingredient is determined by the size of the molecule and other characteristics of the product. Lipid-soluble products penetrate better. The routes of penetration are through the follicle walls, sebaceous glands, intercellular, or transcellular, figure 3-5. Small molecules with permeable cell walls can penetrate the cells. Larger cells with non-permeable cell walls can be temporarily absorbed by the glands in the skin and can travel through the intercellular spaces. Absorption of select topical products helps keep skin moisturized, nourished, and protected. Scientific advances continually result in the creation of new products that are more readily absorbed by the skin, thus making them more effective. New nanotechnology transforms skincare products, micronizing the particles, so they are able to penetrate further into the skin. Many skincare ingredients, including prescription creams, can penetrate the skin's deeper layers. This effect can be either harmful or beneficial, depending on the elements in the topical application. Did you know? Intercellular means between the cells and transcellular is across or through the cells. Check in. What are the 6 main functions of the skin? What is the barrier function? How does sebum protect the skin? What is the function of the sudoriferous glands? What roots does the skin have for absorption? Explain the function of each layer of the skin, from the deepest to the surface. The skin comprises 3 main components. 1. The hypodermis or subcutaneous layer. 2. The dermis, and 3. The epidermis. We are going to start at the deepest layer and work our way toward the surface. Figure 3.6. Subcutaneous tissue. The subcutaneous layer, also known as hypodermis or superficial fascia, is composed of loose connective tissue or subcutaneous tissue, also known as adipose tissue. This layer is 80% fat. This tissue creates a protective cushion that gives contour and smoothness to the body, and it is also a source of energy for the body. Vessels, nerves, fibers, adipose cells, and fibroblasts are just some of the components of hypodermis. This layer decreases and thins with age. A client with a thick subcutaneous layer may have an underlying hormonal disorder and will deserve further exploration when you perform your skincare consultation. Fat storage in the body is also influenced by hormones and may be reflected, for example, by acneic breakouts, hair growth, excessive oiliness or dryness. The dermis. The dermis, also called the derma, corium, cutis, or true skin, is the support layer of connective tissues above the hypodermis. The dermis, which is about 25 times thicker than the epidermis, consists of 2 layers, the reticular layer below and the papillary layer above. The dermis primarily comprises of connective tissues made of collagen protein and elastin fibers. The dermis supplies the skin with oxygen and nutrients through a network of blood vessels and lymphatic channels. The reticular layer. The reticular layer, the denser and deeper layer of the dermis, is comprised mainly of collagen and elastin. Damage to these elastin fibers as they break down is the primary cause of sagging, wrinkles, and intrinsic aging, loss of elasticity in the skin. Stretch marks are caused by damaged elastin fibers. Collagen and elastin are broken down by ultraviolet, UV, damage, smoking, and environmental influences such as air pollution. Figure 3.7. The papillary layer. The papillary layer connects the dermis to the epidermis. The dermal papillae are membranes of ridges and grooves that attach to the epidermis. Attached to the dermal papillae are either looped capillaries that nourish the epidermis or tactile corpuscles, the nerve endings sensitive to touch and pressure. Note that papillae in the hair follicle are called hair papillae and are the small, cone-shaped structures at the bottom of hair follicles. The blood supplies nourishment within the skin through capillaries. The papillary layer comprises 10 to 20% of the dermis. Collagen and elastin are loose and more widely spaced here than in the reticular layer. Did you know? Collagen is the most abundant protein in the body and is derived from the Greek words kala for glue and gen for to produce. Collagen is a protein substance of complex fibers that gives skin its strength and is necessary for wound healing. Produced by fibroblasts, collagen makes up 70% of the dermis. Fibroblast cells produce proteins and aid in the production of collagen and elastin. In contrast, elastin makes up a small percentage of the dermis. There is approximately 1/15 the amount of elastin compared to the amount of collagen. Elastin is the fibrous protein that forms elastic tissue and gives skin its elasticity. Glycosaminoglycans are large protein molecules and water-binding substances found between the fibers of the dermis. GAGs are polysaccharides, that is, protein and sugar complexes. Glycosaminoglycans work to maintain and support collagen and elastin in the cellular spaces, keeping protein fibers in balance. They also help collagen and elastin retain moisture. They interact with copper peptides in our system for cellular repair. A healthy fluid intake is essential to keep the gags functioning properly. Beneficial hydrating fluids such as hyaluronic acid are part of this dermal substance. Hyaluronic acid is a GAG. Ingredients that duplicate these natural intercellular fluids are important in aesthetics and skincare products and are discussed in other chapters. Did you know? Collagenase and elastase are enzymes that help protect collagen and elastin. However, when excessive levels are produced in response to UV radiation or other damage, it causes dermal breakdown, hyperpigmentation, rhytides, wrinkles, and premature aging. Blood and lymph vessels, capillaries, follicles, sebaceous glands, sudoriferous glands, sensory nerves, additional receptors, and the erector pili muscles are all located in the dermis. Lymph vessels remove waste products, bacteria, and excess fluid. Fibroblasts, cell stimulators, lymphocytes, infection fighters, Langerhans cells, guard cells, mast cells, involved in allergic reactions, and leukocytes, white blood cells to fight infections, are all found in the dermis. Other components give tautness, or firmness, to the skin by interacting with elastin and hyaluronic acid. Hormones such as epidermal growth factor, EGF, and fibroblast growth factor, FGF, stimulate fibroblasts, cells, proteins, and DNA synthesis. In the dermis is a fluid called extracellular matrix, ECM, composed of collagen, other proteins, and GAGs, glycosaminoglycans. These intercellular substances comprise fluid with other components to maintain balance, provide dermal support, and assist cell metabolism, growth, and migration. Dermal/epidermal junction. The dermal/epidermal junction, DEJ, connects the dermis to the epidermis. This junction consists of layers of a connective collagen tissue with many small pockets and holes. Collagen fibrils from the dermis are embedded into these layers to provide strength and adhesion. Keratin filaments on the epidermis side also ensure strength and adhesion to the junction. Some states define the esthetician's scope of practice as not beyond the DEJ, meaning the esthetician cannot treat the skin beyond the epidermis. The epidermis. The epidermis is the outermost layer of the skin. This is the epithelial tissue that covers our body. It is a thin, protective covering with many nerve endings. The epidermis is composed of the 5 layers called strata, singular, stratum, figure 3:8. Stratum germinativum are the germination or growth layer, bottom layer, basal cell layer. Stratum spinosum, the spiny cells. Stratum granulosum, the grainy cells. Stratum lucidum, the clear cells, present only where the skin is thick, on the soles of the feet and the palms of the hands. Stratum corneum, the horny cells. Understanding how the skin cell layers function is important in choosing ingredients and treatments. Estheticians' scope of practice references working on the epidermis, not the dermis, unless they are working under the direction of a physician or other licensed medical practitioner, such as a nurse practitioner, naturopathic physician, or physician assistant. The stratum germinativum. The stratum germinativum, also known as the basal cell layer, is located above the dermis and is composed of a single layer of basal cells laying on a basement membrane. In this active layer, stem cells undergo continuous cell division, mitosis, to replenish the skin cells that are regularly shed from the surface. Stem cells are basically mother cells that divide to produce daughter cells in a remarkable process. Mother cells divide to form 2 daughter cells. Some stem cells and daughter cells always remain undifferentiated and keep dividing for constant self-renewal over a lifetime. These either remain stem cells or are programmed to become something else, such as a keratinocyte. In the body, some daughter cells go on to become skin cells. Other cells become glands, follicles, tissues, or organs. Daughter cells that are not able to divide anymore have the capability to program themselves to end up as one specific type of cell. This is known as terminal differentiation. Cells such as these keratinocytes begin their journey of terminal differentiation as they migrate to the surface and eventually become strong and protective. Did you know? Stratum germinativum, the basal cell layer, is where everything starts or germinates. Basal means the fundamental, or basic, layer. Cells in the basal layer produce the necessary lipids that form cell membranes and hold the cells together. Merkel cells, sensory cells, are touch receptors also located in the basal layer. The stratum germinativum also contains melanocytes, which are cells that produce pigment granules in the basal layer, figure 3.9. About 5 to 10% of the basal cells are melanocytes. The pigment-carrying granules, called melanosomes, then produce a complex protein, melanin, which determines skin, eye, and hair color. The stratum spinosum. The stratum spinosum, also known as the spiny layer, is above the stratum germinativum. Cells continue to divide and change shape here, and enzymes are creating lipids and proteins. Cell appendages, which resemble prickly spines, become desmosomes, the intercellular structures that assist in strengthening and holding cells together. Desmosomes are keratin filaments, the protein bonds that create the junctions between the cells. These strengthen the epidermis and assist in intercellular communication. Also found here are the Langerhans immune cells, which protect the body from infections by identifying foreign material, antigens. The immune cells help destroy these foreign invaders. Keratinocytes and melanocytes work in synergy here, forming the even placement of pigment granules. Lamellar granules are cells that contain lipids to maintain the barrier function. The spinosum is the largest layer of the epidermis. The stratum granulosum. The stratum granulosum, also known as the granular layer, is composed of cells that resemble granules and are filled with keratin. The production of keratin and intercellular lipids also takes place here. In this layer, enzymes dissolve the structures, desmosomes, that hold cells together. As these cells become keratinized, they move to the surface and replace the cells shed from the stratum corneum. Natural moisturizing substances such as triglycerides, ceramides, waxes, fatty acids, and other intercellular lipids are made here and are excreted from cells to form components of the skin's waterproofing barrier function of the top layer. These water-soluble compounds are referred to as natural moisturizing factors, NMFs, and hydrate the lipid layer surrounding cells, absorb water, and prevent water loss. The stratum lucidum. The stratum lucidum is a thin, clear layer of dead skin cells under the stratum corneum. It is a translucent layer made of small cells that let light pass through. This layer is thickest on the palms of the hands and soles of the feet. The keratinocytes in this layer contain clear keratin. The cells here release lipids, forming bilayers of oil and water. The thicker skin on the palms and soles is composed of epidermal ridges that provide a better grip while walking and using our hands. This layer also forms our unique fingerprints and footprints. The stratum corneum. The stratum corneum, also known as the horny layer, is the top, outermost layer of the epidermis. The esthetician works extensively with this layer. The stratum corneum is very thin, yet it is waterproof and permeable, regenerates itself, detoxifies the body, and responds to stimuli. Keratinocytes on the surface have hardened into corneocytes, the waterproof protective cells. These dead protein cells have dried out and lack nuclei. This layer is referred to as the horny layer because of these scale-like cells. Keratinocytes are continually shed from the skin in a process called desquamation. These cells are replaced by new cells coming to the surface from the lower stratums. This process of desquamation and replacement is known as cell turnover. The average adult cell turnover rate is every 28 days depending on a person's age, lifestyle, and health. The cell turnover rate slows with age. Average cell turnover when you are a baby is 14 days. In your teens, your cells are replaced every 3 to 4 weeks. By the time you are over 50, your cell turnover has slowed to 42 to 84 days. Understanding the process of cell turnover will help you make better decisions about how to treat aging skin. Cells and oil combine to form a protective barrier layer on the stratum corneum. Lamellar granules are secreted from keratinocytes, resulting in the formation of an impermeable, lipid-containing membrane that serves as a water barrier and is required for correct skin barrier function. These bodies release components that are required for skin shedding, desquamation, in the stratum corneum. This is the acid mantle. Stratum corneum cells are surrounded by bilayers of oil and water. Lipids of the cell membranes, such as phospholipids and essential fatty acids, determine the health of this protective barrier. To clarify, a bilayer is a thin polar membrane made of two layers of lipid molecules. These membranes are flat sheets that form a continuous barrier around all cells. The cell membranes of almost all living organisms and many viruses are made of a lipid bilayer, as are the membranes surrounding the cell nucleus and other subcellular structures. In general, the stratum corneum has 15 to 20 layers of cells. The stratum corneum has a thickness between 0.01 and 0.04 millimeters. The keratinocytes on the surface of the skin are also called squamous, flat, scaly, keratinized cells. There are different terms used to describe the same cells, so it is helpful to remember these surface cells are both flat and hardened, squamous and cornified. Skin color, melanin, melanocytes, and melanosomes. Melanin is the pigment that protects us from the sun. Every person has the same number of melanocytes, or pigment-producing cells. Both internal and external factors affect melanin activation and production. Differences in genetic skin color are due to the amount of melanin activated in the skin and the way it is distributed. Individuals with darker skin and melanin have more activity in their melanocytes. This is an example of an internal factor. An external factor influencing melanin production is sun exposure. Melanin production is stimulated by exposure to sunlight and protects the cells below by absorbing and blocking UV radiation. Melanocyte cells make melanosome spheres, which are transferred to keratinocytes, figure 3:10. Melanosomes carry the pigment granules that provide the skin's color. One melanocyte will deposit pigment-carrying melanosomes into about 30 keratinocytes through its dendrites. Dendrites are the arms, or cellular projections, that branch out to interact with other cells in the extracellular matrix between cells. This process is how pigment darkening occurs. Tyrosinase is the enzyme that stimulates melanocytes and thus produces melanin. It is estimated that there are over 1,000 melanocytes per square mm, 1/8 square inch, of skin. Focus on melanin. Melanocytes are cells that produce pigment granules, called melanosomes. Melanocytes are stimulated to produce melanosomes by the enzyme tyrosinase. Melanosomes carry and produce the protein called melanin. Melanin is transferred to cells from melanosomes through dendrite branches. The body produces two types of melanin: pheomelanin, which is red to yellow in color, and eumelanin, which is dark brown to black. People with light-colored skin mostly produce pheomelanin, while those with dark-colored skin mostly produce eumelanin. Individuals with fair skin have approximately 20 melanosomes per keratinocyte, and people with dark skin have about 200 melanosomes per keratinocyte. Products that suppress melanin production by interrupting biochemical processes are referred to as brightening agents. Some are called tyrosinase inhibitors. These products are designed to reduce hyperpigmentation. Pigmentation disorders are discussed in Chapter 4, Disorders and Diseases of the Skin. Products and treatments for hyperpigmentation are discussed in other chapters. We have covered a lot of information so far. A summary of the main components of the skin, including their respective layers and functions, is provided here. Subcutaneous layer, hypodermis, or superficial fascia, loose connective tissue, also known as adipose tissue, 80% fat, creates a protective cushion that gives contour and smoothness to the body, is a source of stored energy. Dermis, divided into two subdivisions, reticular and papillary, fibroblasts and immune cells are found in these layers. Reticular layer, collagen and elastin, glands, blood and lymph vessels, nerve endings, intercellular fluids. Papillary layer, touch receptors, blood vessels, capillaries, dermal papilla. Epidermis. Each of the 5 layers of the epidermis contain keratinocytes, immune cells, and intercellular fluids. Stratum germinativum, single layer of cells, cell mitosis, stem cells, Merkel cells, keratinocytes, melanocytes, and lipids are all produced here. Stratum spinosum, large layer, cell activity, desmosomes created, Langerhans immune cells, melanosome pigment distribution. Stratum granulosum, production of keratin granules in cells, additional lipid production and excretion, desmosomes dissolved by enzymes. Stratum lucidum, clear cells, thickest on the palms and soles. Stratum corneum, hardened corneocytes, also referred to as flattened squamous cells, melanin, barrier layer, acid mantle, desquamation. Check in. Name the 2 components of the dermis. Name the 5 layers of the epidermis. What are keratinocytes? Clarify the process of skin melanization. How does the skin repair itself? Identify a hair follicle as an appendage of the skin. Hair is an appendage of the skin. It is a slender, thread-like outgrowth of the skin and scalp. An esthetician needs to understand this appendage in order to perform treatments such as body waxing, sugaring, and brow shaping. Figure 3:11 shows the structure of the hair follicle. There is no sense of feeling in the hair, due to the absence of nerves. Much of the hair on the body is invisible to the naked eye. Heavier concentrations of hair are on the head, under the arms, in the axillary area, around the genitals, and on the arms and legs. Due to hormonal influences, there are different male and female hair growth patterns. Genetics influence the distribution of each person's hair, along with its thickness, quality, color, rate of growth, and whether it is curly or straight. The speed of hair growth is roughly 0.5 inch, 1.25 centimeters, per month, which is about 6 inches, 15 centimeters, per year. With age, the speed of hair growth might slow down to as little as 0.1 inch, 0.25 centimeters, a month. There are 2 types of keratin. Alpha, A keratin, is softer. Beta, B keratin, is harder. Hair contains 90% hard B keratin. It has lower moisture and fat content than soft A keratin does, and is a particularly tough, elastic material. Keratin forms continuous sheets, fingernails, or long, endless fibers, hair. Hard keratin does not normally break off or flake away. It remains a continuous structure. Hair also contains melanin, which determines hair color. Abnormalities such as extremely curly hair and/or rapidly growing bacteria and the inability of the follicle to take in oxygen, along with excessive sebum production, can contribute to ingrown hairs and folliculitis, an inflammation of the follicle. Hair growth is discussed extensively in Chapter 11, Hair Removal. Check in. What influences hair growth? What kind of keratin does hair contain? Identify nails as an appendage of the skin. The nail, an appendage of the skin, is a hard translucent plate that protects fingers and toes. The nail is composed of hard keratin. Figure 3:12 shows the nail structure. Onyx is the technical term for the nail. The hard, or horny, nail plate contains no nerves or blood vessels. Fingernails grow faster than toenails and grow faster over the summer than over the winter, lengthen about 110 inch to 18 inch, 2.5 millimeters to 3 millimeters, per month, which means that it takes a fingernail about 4 to 6 months to fully grow out. An esthetician may work in a state where performing nail services is part of the scope of practice. Additionally, some symptoms of diseases and disorders that influence the skin are evident on the nails. A person with a circulatory disorder may have cyanotic nails, for example. Cyanosis is when a person has a purple or bluish tone under their fingernails. Check in. What kind of keratin do nails contain? Describe the functions of the 2 types of nerves. Nerves are cord-like bundles of fibers made up of neurons through which sensory stimuli and motor impulses pass between the brain or other parts of the central nervous system and the eyes, glands, muscles, and other parts of the body. nerves form a network of pathways for conducting information throughout the body. There are two types of nerves, motor and sensory. Motor, or efferent, nerve fibers convey impulses from the brain or spinal cord to the muscles or glands. These nerve fibers stimulate muscles, such as the erector pili muscles, attached to the hair follicles. Erector pili muscles cause goosebumps when you are cold or frightened. Secretory nerve fibers are motor nerves attached to sweat and oil glands. They regulate excretion from the sweat glands and control sebum output to the surface of the skin. Sensory, or afferent, nerve fibers send messages to the central nervous system and brain to react to heat, cold, pain, pressure, and touch. Check in. Name the two main types of nerves and describe what they do. Explain what is produced by the two types of glands of the skin. The dermis of the skin contains two types of duct glands, each producing different substances. The sebaceous glands secrete oil, while the sudoriferous glands excrete sweat, figure 3.13. The sebaceous, oil, glands. Sebaceous glands are connected to the hair follicles and produce oil, which protects the surface of the skin. Glandular sacs open into the follicles through ducts. If the ducts become clogged, open or closed comedones, blackheads or whiteheads, are formed. The oily secretions lubricate both the skin and hair. Sebaceous glands are larger on the face and scalp than on the rest of the body. Other chapters include further discussion on sebaceous glands and acne. The sudoriferous, sweat, glands. Sudoriferous glands help to regulate body temperature and eliminate minute amounts of waste products by excreting sweat. They have a coiled base and duct openings at the surface, known as pores. Fluids and minerals are eliminated daily through these pores. Excess fluid loss can result in the loss of electrolytes, which may lead to dehydration in the body. The excretion of sweat is controlled by the nervous system. Normally, 1 to 2 pints, 0.5 to 1 liter, of fluids containing trace amounts of minerals such as sodium, potassium, and magnesium are eliminated daily through sweat pores in the skin. There are two kinds of sweat glands, apocrine and eccrine. Did you know? Apocrine glands produce chemicals known as pheromones. Pheromones are hormones that trigger biological reactions or communicate signals to others. This reaction is thought to attract others through scent production and is commonly called body chemistry. The apocrine glands are coiled structures attached to the hair follicles found under the arms, in the axillary region, and in the genital area. Their secretions are released through the oil glands. Apocrine function is sensitive to adrenaline, so sweating can occur during times of anxiety, stress, fear, sexual arousal, and pain. Odors associated with these glands are due to the interaction of the secretions and bacteria on the surface of the skin. According to some medical authorities, apocrine glands are not true sweat glands because their openings connect to oil glands instead of pore openings directly on the skin's surface. The eccrine glands are found all over the body but are primarily on the forehead, palms of the hands, and soles of the feet. They have a duct and pore through which secretions are released on the skin's surface. These glands are not connected to hair follicles. Eccrine glands are more active when the body is subjected to physical activity and high temperatures. Eccrine sweat does not typically produce an offensive odor. Check in. What glands help regulate the body's temperature? What are the two main glands associated with the skin? What are the two types of sweat glands? Distinguish the factors influencing skin health. In order to survive, cells need these important elements: nourishment, protection, and the ability to function properly through respiration, circulation, elimination of wastes, and continual replacement or proliferation. Skin health and aging of the skin are both influenced by many different factors, including heredity, sun exposure, the environment, health habits, nutrition, and general lifestyle. This topic is discussed thoroughly in Chapter 5, Skin Analysis. The immune system and the skin. Our immune system is a complex defense mechanism that protects the body from foreign substances. The immune system is activated when antigens, foreign invaders, are identified. Antibodies are molecules formed to fight and neutralize bacteria, viruses, and antigens. Langerhans cells, T cells, and leukocyte cells are part of the immune system. Langerhans cells are dendritic in form. They are present predominantly in the stratum spinosum, but also other layers of the skin. They work to absorb, process, and carry antigens to the nearest lymph node for further immune system action. Another part of the immune system involves leukocytes, leukocytes, the white blood cells that have enzymes to digest and kill bacteria and parasites. These white blood cells also respond to allergies. A T cell, is a type of lymphocyte. T cells play an important role in the immune system by attacking virus-infected cells, foreign cells, and cancer cells. T cells get their name from the thymus gland, where they mature. There are additional components of the immune system that protect the body from foreign substances, bacteria, and infections. Infections and allergic reactions speed up cell growth and migration rates for faster healing. The skin's capacity to heal, fight infection, and protect itself is truly extraordinary. Skin nourishment. Blood and lymph are the fluids that nourish the skin, Figure 3:14. Networks of arteries and lymphatics send essential materials for growth and repair throughout the body. Water, vitamins, minerals, and other nutrients are all important for skin health. Blood supplies nutrients and oxygen to the skin. Nutrients are molecules from foods such as protein, carbohydrates, and fats. Topical products with small molecules can nourish the epidermis. Lymph, the clear fluid of the body that resembles blood plasma but contains only colorless corpuscles, bathes the skin cells, removes toxins and cellular waste, and has immune functions that help protect the skin and body against disease. Networks of arteries and lymph vessels in the subcutaneous tissue send their smaller branches up to dermal papillae, follicles, and skin glands. Cell protection. The health of skin cells depends on the cellular membrane and the water-holding capacity of the stratum corneum. Phospholipids, glycolipids, cholesterol, triglycerides, squalene, and waxes are all different types of lipids found in the stratum corneum and cell membranes. Intercellular lipids and proteins surround cells and provide protection, hydration, and nourishment to the cells. Ceramides are a group of waxy lipid molecules such as glycolipids that are important to barrier function and water-holding capacity. 50% of the lipids in the stratum corneum are ceramides. Fatty acids are also components of the intercellular substances. Lipids are reduced if the skin is dry, damaged, or mature. Topical products containing peptides, hyaluronic acid, ceramides, and other lipids benefit skin that is damaged from both intrinsic and extrinsic aging. These products expedite the regenerative processes of the body and promote healing. Exfoliation removes and depletes lipids, so topical product reapplication is necessary to balance what was lost in exfoliation. Cell recovery depends on water to function properly, so drinking water and keeping the skin hydrated is essential to keep cells healthy. Cell replacement. The body replaces billions of cells daily. The cells of organs such as the skin, heart, liver, and kidneys are replaced every 6 to 9 months. Cells of the bones are replaced every 7 years. Unfortunately, elastin and collagen are not easily replaced by the body, and the skin does not regain its once pliable shape after being stretched or damaged by UV radiation and environmental pollution. However, research shows that certain skincare treatments and ingredients, such as vitamin A, alpha-hydroxy acids, AHAs, alpha-lipoic acid, and other growth factors stimulate skin cell turnover and reduce visible signs of aging. Regular cell turnover is necessary to keep skin healthy. Sun damage. The sun and ultraviolet, UV, electromagnetic radiation have the greatest impact on how our skin ages. According to the U.S. Department of Health and Human Services, ultraviolet radiation, UVR, is a proven carcinogen. UV exposure alters DNA and can cause skin cancer. Approximately 80 to 85% of our aging is caused by sun exposure. As we age, the collagen and elastin fibers of the skin naturally weaken. This weakening is accelerated when the skin is frequently exposed to ultraviolet radiation. UV reaches the skin in 3 different forms: UVA, UVB, and UVC. Each of the UV forms affects the skin at different levels, Figure 3:15. Cell damage is cumulative, and photodamage, from the sun, causes photoaging. Pigment dysfunction, wrinkles, sagging, collagen and elastin breakdown, and skin cancer result from exposure to UV radiation. UVA radiation, also known as aging rays, contributes up to 95% of the sun's UVR that reaches the Earth's surface. The longer wavelengths of UVA, 320 to 400 nanometers, penetrate deeper into the skin and cause genetic damage and cell death. UVA weakens the skin's collagen and elastin fibers, causing wrinkling and sagging in the tissues. UVA can also penetrate glass and clouds. UVA is present all year and more prevalent than UVB. UVB radiation, also known as burning rays, causes burning of the skin as well as tanning, aging, and cancer. UVB wavelengths range between 290 and 320 nanometers. Although UVB penetration is shorter than and not as deep as UVA, these wavelengths are stronger and more damaging to the skin and can damage the eyes as well. On a positive note, UVB radiation contributes to the body's synthesis of vitamin D and other important minerals. UVC radiation has more energy than UVA or UVB. It reacts with the ozone high in our atmosphere and from human-made sources, such as welding torches and UV sanitizing bulbs that kill bacteria and other germs. The effects of HEV light, or high-energy visible light, is a new consideration when working on the skin, and questioning your client's exposure to this light is a valid inquiry during the consultation. Blue light from your TV, computer, and smartphone, that is, HEV light, is said to penetrate the skin more deeply than UV rays and damage collagen, hyaluronic acid, and elastin. There is some evidence that the light may also worsen pigmentation problems such as melasma. Evidence tying it to skin cancers and deep wrinkles is scant, however, in part because the subject is too new for long-term study results to be available. Melanin is designed to help protect the skin from the sun's UV radiation, but melanin can be altered or destroyed when large, frequent doses of UV are allowed to penetrate the skin. It is important that you advise your clients about the necessary precautions to take when they are exposed to the sun. Sun protection does more than protect the skin, it defends cells from radiation, cell death, tissue breakdown, and premature aging. In addition to taking sun protection precautions, clients should be advised to see a medical professional specializing in dermatology for regular skin checkups, especially if they detect any changes in the coloration, size, or shape of a mole. Home self-examinations are an effective way to check for signs of potential skin cancer between scheduled medical visits. When performing a self-care exam, clients should be advised to check for any changes in existing moles and to pay attention to any new visible growths on the skin. Sun damage, skin cancer, and sunscreens are discussed further in Chapter 5, Skin Analysis, and in other chapters. Free radical damage. All cells in our body like to be in a state of homeostasis, from individual body systems to microscopic cells. Molecules are in balance when electrons are paired. Molecules may lose an electron due to damage from UV rays, the environment, poor nutrition, unhealthy lifestyle, or injuries. Inflammation creates free radicals. Free radicals speed the aging process and creates an unhealthy state. Free radicals have an unbalanced electrical charge. They are unstable and a chain reaction of cellular destruction begins as they steal electrons from other molecules to try to put themselves back into a state of balance. Figure 3:16. These free radicals are reactive oxidants, derived from reactions with oxygen molecules, searching the body for other electrons that will allow them to become stable, neutral molecules again. Free radicals take electrons from compounds in the body such as proteins, lipids, and DNA. This process destabilizes and oxidizes the once healthy molecules and creates more free radicals. Figure 3.17. Free radicals are superoxidizers that not only cause an oxidation reaction but also produce new free radicals in the process. The prevention of free radical formation is a critical process and a complex task that is necessary for cells to survive. Antioxidants are components that have an extra electron. Antioxidants are vital to neutralize this chain reaction by donating their electrons to stabilize the free radicals' electrons. Proteins, enzymes, vitamins, and metabolites are all antioxidants. Skin cells have built-in antioxidants to protect against sun damage, but their ability to protect cells deteriorates with sun exposure. The melanin pigment produced by tanning darkens the skin and absorbs UV radiation to help keep cells below from being damaged. Skin health and the environment. While the sun may play the predominant role in how the skin ages, changes in our environment also greatly influence this aging process. Pollutants in the air from factories, automobile exhaust, and even secondhand smoke can all influence the appearance and overall health of our skin. While these pollutants affect the surface appearance of the skin, they can also change the health of the underlying cells and tissues, thereby speeding up the aging process. Climate, humidity levels, and other environmental factors also affect the skin. Routine cleansing at night helps to remove the buildup of pollutants that have settled on the skin's surface throughout the day. Applying daily moisturizers, antioxidants, growth factor serums, peptides, sunscreen, and even foundation products helps to protect the skin from airborne pollutants and the environment. Did you know? Many free radicals are related to the oxygen molecule and are byproducts of our use of oxygen in the energy cycle. In our bodies, free radicals cause the same type of oxidative damage that is observed as fruit decays and turns brown, or when a car rusts as the metal is exposed to oxygen. Our organs also experience damage over time from free radicals. Skin health and lifestyle choices. What we choose to put into our bodies significantly affects our overall health. The impact of poor choices can be seen most visibly on the skin. Smoking, drinking, drugs, and an unbalanced diet with heavily processed foods all greatly influence the aging process. It is the esthetician's responsibility to be aware of how these habits affect the skin and during consultations to stress the benefits of good nutrition, exercise, balanced lifestyle, and stress reduction. Did you know? By inhaling just one puff of one cigarette, we create 3 trillion free radicals in the lungs. Free radicals attack our cells and produce a tremendous inflammatory response. Smoking and tobacco use not only may cause cancer but are linked to the premature aging and wrinkling of the skin. Nicotine in tobacco causes contraction and weakening of the blood vessels and small capillaries that supply blood to the tissues, causing decreased circulation. Eventually, the tissues are deprived of essential oxygen, and the skin's surface may appear yellowish or gray in color and can look dull. Figure 3.18. Lack of oxygen and nutrients accelerates skin aging. Using some prescription or illegal drugs also affects the skin. Certain drugs have been shown to interfere with the body's intake of oxygen, thus affecting healthy cell growth. Some drugs can even aggravate serious skin conditions, such as acne. Other effects include dryness and allergic reactions on the skin's surface. As more states move to legalize marijuana, the effects of inhaled cannabis should be a consideration in the skin's aging processes as well. There may be documentation about the benefits of skincare containing cannabinoids. However, inhaling marijuana has a detrimental effect on the skin. There is a correlation between marijuana and testosterone that may cause increased acneic breakouts as well as deprive the skin of needed oxygen, further breaking down collagen and elastin. Similarly, consuming alcohol has a damaging effect on the skin. Heavy or excessive intake of alcohol dilates the capillaries and other blood vessels. Over time, this constant overdilation and weakening of the fragile capillary walls can cause them to expand and burst. This causes a constant flushed appearance of the skin and red splotches in the whites of the eyes. Alcohol can also dehydrate the skin by drawing essential water out of the tissues, making the skin appear dull and dry. When dehydrated, skin is in an inflammatory state that also accelerates the aging process. Alcohol in excess results in a rapid and sustained increase in blood sugar, which causes inflammation and a glycation reaction. See details on glycation in the following section. In addition, alcohol is metabolized by the liver into chemicals that are toxic to cells. Both smoking and drinking contribute to the aging process on their own, but the combination of the two can be even more damaging to the tissues. The constant dilation and contraction of the tiny capillaries and other blood vessels, as well as the constant deprivation of oxygen and water to the tissues, quickly makes the skin appear lifeless and dull. It is very difficult for the skin to adjust and repair itself from this assault. Damage done by our habits can be hard to reverse or even diminish. Glycation. Recent research indicates that an intrinsic part of the aging process involves damaged structures and tissues that gradually accumulate in the body through a destructive process called glycation, which is caused by an elevation in blood sugar. Glycation is the binding of a protein molecule to a glucose molecule, resulting in the formation of damaged, non-functioning structures known as advanced glycation end products. Glycation alters protein structures and decreases biological activity. For example, glycation contributes to the aging of skin, contributing to wrinkles and hyperpigmentation. Many age-related diseases such as arterial stiffening, cataracts, and neurological impairment are partially attributed to glycation. Scientists have established that anything that causes a rise in our blood sugar results in inflammation on a cellular level. When blood sugar goes up rapidly and continually, the sugar can actually attach to the collagen in the skin, making it stiff and inflexible. This is glycation. When collagen is cross-linked by sugar, it leads to stiff and sagging skin. When blood sugar is elevated, we are in an inflammatory state. For example, lack of sleep elevates the hormone cortisol. On days we do not get enough sleep, we tend to crave carbohydrates because cortisol raises blood sugar and insulin levels, setting up this craving. Even though it is an essential hormone in the body, cortisol has many negative side effects in excess quantities. For example, it can break down muscle tissue, thin skin, decalcify bones, and elevate blood sugar. In summary, glycation is an unhealthy biological process for many reasons. A healthy lifestyle and a diet without excess sugar intake can help keep sugar levels balanced in the body. Aging skin and hormones. As we age, our skin changes significantly. This is partially because of shifts in hormone balance. Hormones are the internal messengers for most of the body's systems and are significant internal factors in the skin's appearance, strength, and health. Estrogen, which is present in both men and women, but is predominant in women, is a crucial hormone for good health and the appearance of skin. Estrogen is anti-inflammatory, an antioxidant, and a key factor in tissue repair. The hormone is also responsible for maintaining health in several areas such as coordination, balance, skin moisture, vision, bones, and the nervous system. Estrogen has even been linked to memory and emotions. Women's skin is continually in a state of change due to hormonal changes in the reproductive and endocrine systems. From puberty to pregnancy, to the postpartum period, to perimenopause, and to menopause, estrogen levels fluctuate. This affects the skin's protective barrier, epithelial, external covering, tissue, and dermis. As skin ages, capillary and other vascular walls begin to weaken, lipids are reduced, the lymphatic system is less efficient, glands slow down, and there are fewer fibroblasts, thus affecting cells, collagen, and elastin, figure 3:19. The skin thins and collagen has less ability to respond to physical changes from aging and sun damage. As estrogen is depleted, skin begins to lose its tone. Reduced glycosaminoglycans mean less moisture in the tissues, keratinocytes are reduced, slower cell mitosis, melanocytes are reduced, less protective pigment, and cellular exchanges are reduced. Testosterone levels become dominant as estrogen decreases, which can increase sebum production, pore size, and hair growth on the face. This helps explain why mature women may experience adult-onset acne or facial hair growth. Microcirculation. Microcirculation is the circulation of blood from the heart to arterioles, small arteries, to capillaries, to venules, small veins, and then back to the heart. Hormonal changes are one cause of the microcirculation problems common in mature skin. One such problem is cuprose skin, or telangiectasia, the dilation of the capillary walls. As the endothelium wall of the capillary atrophies and loses its elasticity, the walls dilate and fill with blood, sometimes bursting. Other causes of vasodilation are heredity, alimentary, digestive problems, alcohol, smoking, sun damage, harsh cosmetics, trauma, pregnancy, excess localized heat, topical corticosteroids, inflammation, and heat-cold fluctuations. These could potentially lead to permanent distension of the capillaries. Rosacea is a chronic vascular disorder characterized by varying degrees of skin redness and congestion of the skin. Acneic rosacea includes papules and pustules. In some cases, rosacea may be caused by parasitic microorganisms, mites. Skin disorders are discussed in Chapter 4, Disorders and Diseases of the Skin. Hormone replacement therapy. Hormone replacement therapy, HRT, is often suggested to balance estrogen for women experiencing menopause. However, some HRT may be linked to breast cancer. These therapies may be derived from animal source estrogens or plant source estrogens. Estrogens from plants are called phytoestrogens. They are about 200 to 400 times weaker than animal estrogens. Plants that provide phytoestrogens include Mexican wild yam, soybeans, red clover, sage, hops, black cohosh, flax, St. John's wort, licorice root, and butcher's broom. Choosing an HRT program should be done with the help of a medical professional. It is not within the scope of practice of an esthetician to make recommendations. In addition to hormone balancing, sustaining good nutrition, the use of good skin care products and treatments, exercise, and a positive outlook can help keep skin looking radiant at any age. Check in. How do the Langerhans cells, leukocytes, and T cells work to protect the body? Describe the differences between UVA wavelengths, UVB wavelengths, UVC wavelengths, and HEV light and their effect on the skin. How do antioxidants stop free radical damage? What environmental influences affect skin health? What happens to the skin during the aging process?